the okay. So is the screen visible?
Yes, Abha.
Okay. So as I told you earlier that we are going to start with first briefly, I sort of intend to cover an hour of the presentation, and then I'll take maybe 10-20 minutes to navigate the website. And then if you have any questions, you can pose it. Pratiksha, you is moderating the whole session today. So in case you have any queries in between, because there'll be a lot of technical jargon that I'll try to sort of simplify and introduce new terms to you. So in case you sort of you want me to revisit a certain concept, please don't hesitate to interrupt, because this is otherwise, when you look at IPCCs, otherwise on the face of it looks very complicated. So if you have any doubt, I will touch upon. I will not I'm going to cover the breadth, not go too much into the depth, but still, if you have any doubts, please don't keep it to yourself. Raise your hand. I may not be able to see you. Pratiksha will be able to see your raised hands, and she'll interrupt me in between. And any doubt you have, please interrupt me to ask, because that is the basic objective. And there'll be no question I'll rate as silly questions. All questions are good questions because they clear your doubts. So what I'm going to cover today is what is IPCC, the basic structure of it, what are the main reports that it has presented, latest ones, and why is it important to understand IPCC reports. Then the second section would be on understanding. So what are the different types of report? What is the process by which the reports are produced and how they're reviewed, and how as an individual or as an organization or as a researcher, you can engage with the IPCC process, because that is very much possible for any citizen, any global citizen. You can directly be a part of the IPCC process when they prepare the reports. And then I will take you through the key findings, not the content of it, but how to navigate the entire IPCC website and access it. So first thing, what is IPCC? It is basically set up in 1988 and a joint venture by WMO, which is the World Meteorological Organization. It is a UN body, and by UNEP, which is the United Nations Environment Program. So a joint venture of WMO and UNEP. The WMO is basically a scientific organization. You'll find within UN, organizations working on development, on health. So you have on labor, on child refugees, and ILO, and you list, there are so many UN bodies, but WMO is a purely technical World Meteorological Organization. You can visit the website, see what is the type of work that they're doing. UNEP works basically on the environment area. So it's a joint collaboration between WMO and UNEP. What it does, its basic task is to undertake regular assessments. So IPCC is intergovernmental. I'll go back here. It is Intergovernmental Panel on Climate Change. So who are the representatives of IPCC? The members are, say, suppose I say India, so a member who's nominated by Government of India. So you and I, if we are not a part of the government machinery, we will not represent India in the IPCC. It will be always a government membership. So it is an intergovernmental body. Second thing, it is an international body. So you have roughly you have about 190 plus members as of now. Its basic work is to conduct assessment. They are pure, hardcore scientific assessments. So which are assessments of what? Its broad thematic area that it deals with is climate change. Now, if you talk of climate change, then everything under the sun these days is climate change. You talk of economics, you talk of health, you talk of infrastructure, you talk of environment, you talk of biodiversity, you talk of oceans, land, energy. Anything that you can think of is affected by climate change. So broadly, why it came into being in 1988 was that that need was felt that when you talk of climate change and anthropogenic means the human-induced component of climate change, there was a realization, and there's a huge history. All of you who've been working in sustainability will be aware of it, that somewhere around mid-century, last century, 1950s, 60s, there was a huge global environmental movement that took place towards environment. And the realization was that, there was scientific evidence emerging very much in the peer-reviewed journal that climate is getting changed. So there was a requirement at the global level, that need was felt that you need a scientific body to assess the changes. Who is going to peg it? So there was a body which came up, which is the IPCC. So it does the assessments of what is the scientific basis, then what are the impacts and future risks. I will cover, sort of try to demystify these terms as we go ahead. And once you understood how the climate is changing, what is the impacts it has presently, what is the future risk that it will pose. So we are talking about the present, and what is climate otherwise per se, as per definition, you see, is basically an average weather for a minimum period of 30 years. So something which is a cumulative that comes up based on past weather. So say suppose over 30 years you found that this is how the weather is changing. So on the basis of past, you formulate a climate, then see that how that climate is changing. Because of the change of the climate, what are the impacts? And because of these impacts and the way in which the climate is changing, what are the future risks? So when we talk of why it is important, it is also because of the present impact. It is also because of the future risk that it poses. And then what will the assessment tell us? It will tell us the options for adaptation and mitigation. What is adaptation and mitigation? The measures that you take to reduce greenhouse gas emissions, GHG emissions ko kam karne ke liye, the measures that you take that come under mitigation. And the climate impacts, the way you prepare yourself to handle the climate impacts, those measures are called adaptation. So climate change, basically when you talk of climate change, you always heard these words, you will always hear this word, adaptation, mitigation, adaptation. So mitigation is something which is long term, but what you're going to do today, so because of that, your emissions are going to change. So measures to reduce the emissions are mitigation. And if you reduce the mitigation, if you reduce the emissions today, how it will change the future weather, that will play out over a longer period of time. Say suppose today we reduce our emissions, say to, so will the weather improve? Will weather come back to its normal or baseline scenario or not? No, it will take, because the greenhouse gases that are there in the atmosphere, they have a certain lifetime. They decay over a period of time. So the climate impacts will also decay as the greenhouse gases decay. So the mitigation is, so basically you need those climate impacts will be there for some time. So to prepare for the impacts that will be there for some time, for that you need to adapt. So this basic construction you should be clear in your mind. Then one thing that is, when you look at IPCC assessments, you have to be very clear that assessments are policy relevant, but not policy prescriptive. What does it mean? Policy relevant means whatever assessments or whatever comes out of it. Whatever comes out means whether you get an understanding of impacts or of the future risk, all the options for adaptation and mitigation. So whatever suggestions or recommendations come out of IPCC, they are relevant for policy makers. But IPCC does not have the mandate or the authority to make it policy prescriptive. It cannot tell a country government that this is what the science says and now you have to do it. It cannot prescribe solutions. It can only give you recommendations. So that is the difference between, policy relevant and policy prescriptive. They tell you this all is, you are say, suppose we talk of South Asia, we talk of India, so we'll say this is how the impacts are, this is how the future risk is going to change, and this is what can be done to adapt or to mitigate. But then they will not add that sentence that India should do this, Bangladesh should do this, Pakistan should do this. No, not policy prescriptive. So they present the assessments, they present the future climate change projections based on different scenarios. I will explain very clearly a little later what are projections and what are scenarios, because these words, they are used very frequently when you take out anything that IPCC is working around. So projections, scenarios, future risk projections, scenarios. I'll explain and try to reconstruct what it is. It presents the climate change risk and discusses the implications of response options. What are response, mitigation, and adaptation? So there's another term that you'll find. When, if you have been following the debate, what are the response measures and what are the market mechanisms? So what are the response measures? Adaptation and mitigation together, the term is known as response option. So it will present you the risk and it will tell you what are the implications of different adaptation and mitigation strategies. Now, currently we have about 195 members. So all the countries which are member of WMO or of the United Nations, they are they can be members of IPCC. So currently we have 195 member states or countries which are member of IPCC. Now, how the IPCC works out, it works out in two manners. It has a panel and it has a bureau. So panel, all the member countries, they together form the panel. So they are representatives of member states. And then they have their annual plenary sessions where the panel meets. So the panel has got a plenary and there they take all the decisions. So it's not that IPCC decides that we'll make a special report on warming of 1.5 degrees Celsius. That report is made and it is accepted. No, there's an organization structure in place. They have a governance mechanism. So anything that comes out of IPCC is approved by the panel. Anything which is not approved by the panel is not published by IPCC. So this is the body, and because they have got, every member has got equal vote, so every country is equally represented as far as IPCC panel is concerned. Now the bureau is, it's like a smaller body. Like we have, to give you a correlation, we have we have members or Indian citizens, and then we have a member of, say at a state level, we have a legislator, at central level, we have a member of parliament, which was elected members. So similarly, IPCC bureau is a smaller body in which they are elected members. These same amongst the representative, few members are elected and they form a shorter body, which is called a bureau. So what is the work? Similar, if you can see the governance structure, it provides the guidance to the panel on scientific and technical experts, and it advises the panel on management. And so one part is the operational aspect of it. Another thing is the scientific aspect of it. So bureau undertakes that responsibility. Now have a look at this. So you have WM and UNEP, which are the body which are basically responsible, jointly formed IPCC under it. So you have a plenary, which is all members. You have a bureau, which is a shorter number of members. The secretariat looks after all the coordination functions. Now the question that we had, that Pratiksha had shown you in the morning, how many groups are there? How many working groups and task force are there? So when you look at the assessment reports, so there are basically three groups. There's work 1, 2, and 3, and there's a task force. It is called TFI, Task Force on Inventories, which is National Greenhouse Gas Inventory. So what is the work of these four structures? If you have any assessment report, the latest one that has come out is AR6, or the 6th assessment report. So that report has got 3 pillars. First is the physical science basis. That is purely climate science. So the most technical or the hard-hitting technical component is this. It has got everything scientific, everything that is related to climate science. So this is a working group, and it has got a technical support unit. TSU stands for Technical Support Unit. This will be responsible for producing the working group 1 report, which will be the physical science basis for assessment and document. The second work group basically looks after the impacts, adaptation, and vulnerability. So of the response measure, adaptation is basically dealt in the second working group. The third working group looks after mitigation. So when your report comes out, your report is a combination of, it is called WG1. So WG1, 2, and 3. So different chapters are prepared by the 3 working groups. They are stitched together. From all these 3 together, we have a synthesis report, which is a shorter version, condensed version. And from the synthesis report, somewhat similar to the synthesis, much shorter version is called a SPM, or Summary for Policymakers, which is basically because they are hugely technical reports. They are big and they are technical. So what you do is, whatever recommendations have come out of these assessments, they are made in a smaller publication, which is called SPM, or Summary for Policymakers. Basically, the recommendations that the IPCC is making, which are relevant for policymakers. So a quick ready reference, it comes out of it. Now, what does the TFI does? Because if you look at, IPCC is giving you projections based on your greenhouse gas emissions. So how that greenhouse gas inventory would be made by a country. Those guidelines are for your national greenhouse gas inventory, or for otherwise some other small technical matters, are prepared by these task force, this task force. So this task force is basically responsible for your methodology reports, how to do a particular task. So a standard methodology, which will be used by all countries, that the TFI makes. The assessment, various types of assessment, is looked after by 3 work groups. How these things are prepared, they're prepared by authors, contributors, and reviewers. I'll cover later on what they are. So if I now you have a look at,
Abha, can you go a bit slow, because there are few participants who are not into this space, and they want to understand it really better.
Okay, so I'll just go back again.
Yeah, just slow.
Okay, so how the IPCC works is, there are 3 groups. Working group 1 that deals with the climate science, projections, scenarios. Group 2, which works with impacts, means climate change impacts. Vulnerability you understood. I will not explain it more because I have time paucity, but if you have a certain risk, climate risk, whether you're exposed to it, whether you have the capacity to do it. So all those components, when they interact, finally it decides whether you're vulnerable or not, and then whether you need to adapt or not. So all those components of this, in short, is called IVA, impact, vulnerability, and assessment. That is looked after by working group 2. And the third group looks after mitigation, and everything that is related to mitigation is looked after by group number 3. So this is as far as the assessment is concerned. So when a climate, say we are talking about first assessment report, we are currently, the latest one that has come out is the synthesis report of 6 cycle, AR6. So it is basically 3 groups which have worked on it. And the 4th group works on methodological reports. Methodological reports means how to standardize a method through which your greenhouse gas inventory will be made. I'll show you more when I navigate the slides later on. Now, so what are the reports that have come out? Just to walk you through, not the content, just the timeline. So the first 1988 IPCC was formed. 1990, we had the first assessment report, which is called FAR, basically an acronym for first assessment report. And what was its main purpose? If you look at the governance of climate change, the first international convention that came out on climate change is called Rio Convention, or the bigger word is United Nations Framework Convention on Climate Change, generally known as UNFCCC. So the first assessment report basically was a scientific assessment which provided a grounding for the UNFCCC. Then thereafter, once the 1992 UNFCCC was agreed, and thereafter UNFCCC had a long-term goal of stabilizing the anthropogenic emissions, means the emissions which are made by human activities. The main objective of the convention was stabilize those emissions. So now to guide how that work towards that long-term goal should be aligned. For that, it was decided that every 4 to 5 years, the IPCC will bring about a huge assessment. So the second assessment report came out in 1995. It is known as SAR. The third one came out 6 years later. It is called PAR acronym. Then from now, it could not have been FAR. Fourth assessment report was the first one, was already FAR. So from there on, they have started as AR5, AR4, AR5, AR6. So the 6th assessment report, which currently now, the synthesis report, which has come up now, the ISCA working group 1 report basically came out in 2021. The working group 2 report came out in 2022. Working group 2 and 3. The synthesis report has just come out in the month of March, last month only, in 2023. So these are the main assessment reports of IPCC. Now, this is, if you look at, this is the 5th assessment report, which I just told you, 2013 to 14. So the first group came out in 13, the second group came out in 2014, and the third group, working group 3, mitigation of climate change, came out 2014. And the synthesis is basically all the 3 reports, they condense it, that is called the synthesis report. We are in the 6th cycle currently. The synthesis report has just come out in March 2023. These are the different, this is working group 1, this is working group 2, and this is working group 3. Now, other than that, we have special and methodology report. I'll cover it more. What are the special reports? So the latest one that have come out are 3 special reports. One is on the global warming of 1.5 degrees Celsius. The second one is on climate change and land. And the third one is on ocean and cryosphere in a changing climate. And the latest methodology report, there are 2. One is on short-lived climate forces, and the second one is the refinement, 2019 refinement to the 2006 guideline. They are basically on inventories. So these 2 are the methodology reports, and these 3, one on 1.5 land and cryosphere, these 3 are the special reports. What are special reports? See, otherwise the IPCC has a mandate to bring out a assessment report every 4 to 5 years. But any UN body or a subsidiary body of UN may request the IPCC to come up with some sort of assessment report. So if you've been following the climate debate, you'll find that 2015, the Paris Agreement came out. And whereas in the UNFCCC, the earlier agreement we had in 1992, the long-term goal was that you stabilize the greenhouse gas emissions so that it does not have adverse effects. Okay, but that was 1992. So our understanding in the last about 15 to 20 years changed. The science improved, and we found that we have to have a more clear-cut goal. So it was decided, the global agreement that came out in 2015 was Paris Agreement. We said that, okay, we will have a long-term goal of keeping the global warming to less than 2 degrees Celsius by 2100 by the end of the century, and maybe try to limit it to 1.5 degrees Celsius if possible. So that came out in 2015. Now you need certain methodology. You've taken a goal. he will try to limit at 2 degrees Celsius and a long-term goal of 1.5. But how do you do that? So to guide that, the path to that trajectory of either 1.5 or 2 degrees Celsius, the UNFCCC, it basically requested the IPCC that you take out a report. You do the assessment of all the scientific literature and you tell us what should we be doing if we have to limit the warming to 2 degrees and long term we limit to 1.5 degrees Celsius. They also asked that what should be the what measures should be taken on land use or on land use change if we want to limit the warming, and what measures should be taken so that the ocean and cryosphere component also gets limited. So the average global temperature does not rise above 2.5 degrees Celsius. So they requested 3 special reports. Paris Agreement requested UNFCCC. Because of that, it took out the special report. So otherwise, if nobody requests, the IPCC will take out assessment reports every 4 to 5 years. But on the request of a UN body, they could take out special reports. Okay. See, I know this is a lot of content, but you have any doubt, you just keep on asking me. Okay. Now, what is the importance? Why is it required? First thing is, when you talk of climate change is it's a very cross-cutting subject. So if I say, suppose I tell you, or if I ask you that just limit ourselves, or just to give an example, you are living in a particular city, just to give you the gravity of the situation, how it works out. So say, suppose you're living in, I live in Delhi, and somebody tells me, or I'm given a mandate that, okay, you have to limit the global warming of local temperatures, chalk out a plan so that by the end of the century, 2100, Delhi's average temperature stays below 2 degrees Celsius. The increase in temperature remains below 2 degrees Celsius, and long term, the objective should be, it should remain below 1.5 degrees Celsius. Now, from where do I start? If I have to do just for a city like Delhi or any place, Nagpur or take Indore or take Coimbatore, any place. So how do you go about it? Because the warming is, now just to go back, how is the warming? I'm trying to see, it is not that simple, but I'm just trying to sort of keep it simplified just for the sake of understanding. So why does the temperature rise in the atmosphere? The temperature rises in the atmosphere because you have greenhouse gases. Greenhouse gases, if you have higher greenhouse gases, the rise in temperature will be more. Why? Because they absorb the outgoing radiation. So if I have higher greenhouse gases, then my temperature rise will be more. Basic fact. So if I have to keep my warming lower, or if I have to keep the temperature rise below to 2 degrees Celsius, then what should be the amount of greenhouse gases that should be limited? Say, suppose if we talk in terms of ppm of CO2, particles per million of CO2. So we say, okay, let us limit it to 400 ppm carbon dioxide or equivalent. I will not go too much into the inventory because it will complicate it further. Just to let us pick up just one component. So if we have to, just for the sake of example, if we have to limit the temperature to below 2 degrees Celsius, temperature rise, to below 2 degrees Celsius, then my carbon dioxide concentration should be 400 particles per million. Now, if I have to limit it to 400, then from where all sources the climate CO2 is coming into the atmosphere, because if I have to maintain a particular concentration, then I have to need to know where all the sources are. So, okay, then I need to do a mapping of all the sources within Delhi. I'm just talking about, say, suppose a 50-kilometer radius only. Now, I find there are many sources. So it is coming out from burning, it is coming out from land, it is coming out from plants, it is coming out from industrial pollution, it is coming out from industries, it is coming out from burning of coal. So I map out all the sources. So now to arrest all those sources, but other than that, there's an inbuilt cycle within the atmosphere. So if I have, say, suppose a carbon cycle or a water cycle, all of you have background in this, I'm not going to go into this. So it is not that it remains static. Everything gets mobilized. It's dynamic, which moves within the cycle. So then you find that the carbon dioxide that's there, it is going into the atmosphere also. So the atmospheric flow will also affect it. Or how I'm using pesticides or fertilizers. If it rains, then it goes into rivers also. So water is also getting affected. Now, if I change a particular land use, say there was a forest, I cut it down, I put a farmland there, then also the emissions will get affected. So the thing is, as you keep on adding the parameters to it, the complexity of it increases. So then it becomes very difficult for you to wrap your mind around that if there are so many factors, and these factors are not static factors, they're dynamic factors. So if I have to maintain a particular temperature goal, And there's so many factors and they're dynamic. Something is increasing, something is decreasing, one activity will change it, one source will change it. Then how am I able to achieve it? So what you do is you then try to give it to, you will say that, okay, there's so many things. Maybe I need some modelers here, maybe who can do climate modeling. I need some scientists, I need some economists, I need some practitioners. So you need a whole lot of people who basically need to deconstruct the whole problem. And then, okay, then they say, okay, then you have to maybe have some law which limits your industrial pollution. You need to have some regulations on the industrial waste. You need to have some regulations at end of pipe for water conservation. So then there are a lot of bodies which come into it. So that is why it becomes important if you have a complex problem. It is, in scientific terms, it is known as a wicked problem. So if you have a wicked problem like climate change, which is intertwined, which has got a lot of causes, a lot of effects. So then what you do is you need to bring a huge scientific body like IPCC to guide you on a broader scale that, okay, this is how you need to go about it. Now, those recommendations are then picked up by either regional associations, regional bodies, or by the national policy makers. And then they try to sort of integrate into their own planning process. So that is why IPCC becomes so important, because another thing is climate change is not a local problem. It is also a global problem, which requires local actions, because you have the whole circulations in the atmosphere, you have the ocean currents which mix, you have so many things through the various natural geochemical cycles. So it is not a nation's problem, it is collectively a global problem. So IPCC basically collects the entire science, does all these experimentations, and not exactly experimentations, those stitching together, filtering, sifting, they give you certain recommendations. So basically it supports your ability to make informed decision making at all levels. So the entire kahani that I gave you about one city planning and why it is complex, just take it to the global level and you'll find, oh my God, you're not able to wrap your head around it. So basically it helps, or it improves our ability to make informed decision making at all levels. At the national level, how it improves, a lot of things, what I covered already. So you have so many social implications, economic implications, if the climate is going to change. So then so what it gives is, it will give you various mitigation and adaptation strategies. Now, as a country, you have to work out whether I have the technology, whether I have the resources, how cost benefit, what is the cost benefit analysis, which mitigation policy will be most suitable to me. So it gives you understanding of the climate risk, it gives you the potential consequences, and it also gives you a mix of recommendations. This is the spread that is available to you. So depending on your own priority areas for action, you design effective policy. That is how it is, why understanding IPCC reports is so important at the national level. At subnational level, say I'm talking about, say Maharashtra government decides, okay, that is a drought prone area, and okay, I need what specific regional climate risk I have and what I need to do in case I have to combat the risk. So you have regional climate also impacts which are provided by IPCC. They give you changes in temperature, precipitation, sea level rise. They give you an idea of the risk, how it is going to affect the ecosystems, how it is going to affect human health, all the other this thing. Because from the national level, if you come down to the subnational level, say state level, regional level, you find the resources become more and more limited. So you, from the spread of response measures that IPCC gives you, you pick out, okay, I have got these specific risks, just depending on my region. I've got this spread of resources available with me. So let me pick out what policy or what strategy is going to work. And then you sort of integrate in your plan. I hope all of you are with me. And there's a lot of content I know, but then if you have any questions, please don't hesitate to ask. It also helps in terms of, say, suppose I'm not a part of national government, I'm not a part of state government or any district administration, I'm an individual. So will it be beneficial for me? Yes, it will be beneficial for me, because it will not give you the granularity that is required at your own level, but it gives you a spread of choices. Okay, adaptation mein ye karna chahiye, mitigation mein ye karna chahiye. Make your own choices, which are possible actions that are possible at individual level. So it helps you make sustainable choices, how you can reduce your own greenhouse gas emissions. And I'll cover resilience also now, because with climate change, it is not only about adaptation and mitigation, it's also about resilience. What is resilience? That if you have a climate shock, say suppose you had a extreme weather even. But say, just to give you an example of Mumbai, because Pratiksha happens to be from Mumbai, you have a very incidence of very heavy precipitation and the entire Mumbai city gets flooded. So you'll find that, your transport is stuck, people are stuck at different places. Because the business, everything comes to a standstill. So the economy comes to a standstill and you have losses in terms of economy, in terms of infrastructure, then you have repercussions in terms of health and everything else. So resilience is that if you are, say, suppose you are given a climate shock. So how do you recover from climate shock and come back to your normal position? That is called resilience. So nowadays we are talking of a lot of resilience in terms of infrastructure, in terms of resilient economies. That's a separate chapter in its separate topic in itself. But so individual may it will help you. Say suppose I decide to purchase a flat for myself. So choices may, then you'll see whether depending on which place you're living. Say suppose you're in a place where you can afford to construct your own house. Then you are, say suppose, just to give you an example, you're in a place which is prone to water crisis, or you're in a place where you're close to coastal region, or you're in a region where there's monsoon, which lies in the region where you receive monsoon rainfall. So what are the choices? You can have a idea about the risk, because when you invest in a infrastructure, like infrastructure is for a longer duration, 30 years, 50 years. So how the climate is going to change over that period of time, you will have a broad outlook, and accordingly you can make choices whether I should have some sort of green architecture or whatever. Choices are many. And then it also helps you in supporting local initiatives for sustainability. So it is not only that IPCC reports are only for national and subnational bodies, it can also help you guide individual action. Now, coming down per se to IPCC reports. So I covered their assessment reports, which are prepared by working group 1, 2, and 3. And of these 3 combined, then you have a synthesis report. Then you have special reports. Like I covered 3 reports on special report on global warming of 1.5 degrees Celsius, on climate change in land, and 1 on ocean and cryosphere. They are prepared only on specific requests to IPCC. Then you have methodology reports, which are basically made by the task force for inventory. And they are basically primarily on greenhouse gas inventory, but now one that you've seen is for short-lived climate forces also. Short-lived climate forces are basically, they pertain to air pollutants which are short-lived. Then it also prepares technical papers on a specific thing, either it has been requested, or within the special reports, if you want a smaller gist, so it prepares technical reports or papers on that. Then it prepares supporting material. What is supporting material? So when these reports or assessment reports or special reports or anything is prepared, there's a long process which is associated with it. So the record of proceedings of those the process documentation for preparation of these reports, or from the expert meetings or some other workshop that IPCC had, that entire documentation basically builds up your supporting material. So if you have a look at the IPCC workshop, you find there's a separate head for supporting material. Okay. So these are the type of documentations and reports that come out from IPCC. Now, say suppose, how are those reports prepared? So I'll broadly go through it. First thing is that, say suppose, just to take an example of special report on global warming of 1.5 degrees Celsius. So the UNFCCC has reported. So first thing is you have a specific report from a UN body. So it will first conduct a scoping exercise. Scoping exercise means a broad outline that how the report is to identify what all should the report cover and what should be the objective. And then you pick up a team of experts which will lead the process. Okay, so that's a broad guideline. So suppose you have, okay, I'll cover this is the aspect. This will be led by this thematic expert, this thematic. Then what you do is, then to prepare the report, you have an author selection. That author selection is done through, there are 2 steps. The first thing is, for experts, the scientists are selected through a call of nomination. And that call of nomination comes from the IPCC to the particular national government. So the IPCC will send, so in India, we have IPCC focal point. And because the IPCC is pegged within the Ministry of Environment, so the Ministry of Environment, whoever is the nodal person, will get a call of nomination. So the entire nomination, it is not that the ministry will nominate one person. So ministry has a huge network through which it has already identified scientists. So all those names will be specifically nominated for different working groups. Within the working groups, if they have provided the details of chapters, so the nomination will be made as per chapters. So that is the first level of selection. Now, the second level of selection would be for lead authors or contributing authors or review editors. That will be done for each chapter. Now, how this is done later on, there's another process built into it because you have coordinating lead authors. I'll cover in the next slide how that is done. So once first thing is, once you've designed it, second thing is you've selected the authors who are going to do it, then you actually draft the reports. So you'll have first a leading author or a contributing leading author who will write these reports. Now these reports will be written based on scientific literature. So you have to understand very clearly that IPCC does not conduct its own research. It's not that IPCC starts on its own. Let us see how the models are going to run or what are the impacts on it. IPCC prepares, it sifts through or picks up all the scientific literature which has been published. So they have their own deadlines. Say, suppose I can tell you if they have decided deadline that maybe 3 months short of one particular time period. If say suppose 2000, they have a timeline that we have to submit this report by 2022, say suppose 2023, whatever time. So maybe by June of 2023 is our deadline. So all the articles, peer-reviewed articles, scientific articles which have been published up to June 2023, only that I will consider. So what will they do is there are thousands of publications that they go through. So they basically cull out all the information which has been published in a peer-reviewed journal. That has to be very clear in your mind. They do not conduct their own research. They do not run their own models. They do not make climate or weather assessments, first thing. Second thing is you have two level of, when you prepare the report, so you have the chapters, and for every chapter, you'll have a technical summary because if you look at the chapters, they are huge. So if you sort of try to read the whole chapter, you'll be lost. Karna kya hai, pata nahi chalega. Technical summaries are there depending on what specific information you're looking for. You can go through the technical summaries and then pick up whichever area. I'll take you through the maybe one of the reports I'll take through in the chapters and how you can pick up whichever area you're looking at. Okay. So once the report is prepared, you go through the scoping is done. And then you go through the draft report is put together, and the draft report it undergoes peer review. But you first pick up from peer-reviewed journals. So you've prepared a draft report, and then it will undergo multiple rounds. First is the first order draft, which is basically published onto the website, IPCC website. It is open for reviewers from all across the world. So you can register yourself, log in through your credentials, and provide which domain you're working on, and you can provide comments on those draft reports. That is the first order draft. So what they do is all the comments are collated, and they'll see whether how those comments can be, whether they're acceptable, not acceptable, whether they need to be incorporated or not. That is the first level of. Once the first order draft comments have been addressed, then the second level is given to the governments. So what happens is the second draft is specifically sent to all the member governments and some of the stakeholders. What are the stakeholders? There's some external observer organizations. They are sent to those organizations. So the second level draft is reviewed by the national governments. Now, once those comments have been taken, incorporated, or sifted through whatever, the next process is the approval process. So the final report which is produced, it is approved by the IPCC. So it basically goes to the plenary session. Now the different terms that are used. If it is a summary for policymakers, it is approval. The term used is approval because every word, line by line, the report is to be approved. For if it is a synthesis report, it is adopted. And once the summary SPM is adopted for one particular report, then the entire assessment report is accepted. So I hope you're understanding this. The approval is for the summary for policymakers, adoption is for synthesis report. And once the SPM is approved, your full AR is accepted. Okay. And how this process is done? This is done first through the plenary session of the working group. Say suppose the plenary session for working group 1 will approve or will accept its report. And finally, from when all the working groups have been done, then it goes to the panel and then the entire report. So it's basically a time-intensive process. Okay. And once the report has been accepted or the SPM has been approved or the synthesis report has been adopted, then what is done is then it is the outreach events. It is the reports are launched and they have various outreach events where they basically want to communicate their findings and their methods. So that is how basically a report is reviewed. Okay. Now, if you want to get engaged with the IPCC process, how you can do it? There are 3 steps. There are 3 gateways through which you can go. First thing is the preparation process, in which you have either authors or the reviewer editors. So CLA is your coordinating lead authors, LA is your lead authors, and RE are your review editors. So these nominations go through the focal point. So either you can get maybe coordinate with the national focal point and get yourself nominated as a CLA, LA or a RE. Now, once they have been nominated, then these CLA and the leading authors, they enlist contributing authors. So maybe if you're not nominated by the government, you can basically become a contributing author through a CLA. So if you have some sort of network through your domain expertise, then you can get enlisted as a contributing author. What you can do is contributing author in turn pick up chapter scientists or author teams who prepare those specific chapters. So this is a 3-step through which you can basically contribute to the writing of the report. You can review the report. Expert review first order is open to everybody. So you can submit your draft there, or you can submit it to the national government also. So you can contribute to the second order draft. And what is the period when the first order draft is available for the public for the reviewers to this? IPCC gives a press release. So what is the duration of the review period and how you can participate? All these details are available. So you can engage directly through in the first order draft as a reviewer, or through your national government in the second order draft. And another thing you can say, if you're a scientist or a researcher and you have published a peer review article, so there are chances that your publication would be reviewed by the IPCC, and then you are basically, your publication gets acknowledged in the report itself. So basically, is because the IPCC prepared its reports through peer review literature. So you can contribute directly as a contributor. Okay. Now the next part is, let me see how much time we have. Now I'll basically walk you through maybe 10 minutes I'll take to walk you through how the reports are. So this, if you look at this is AR working group 1, physical science basis. This is working group 2, impact, adaptation and vulnerability. This is mitigation of climate change, is working group 3. Now, if you look at it, this came out, this is AR6. It means this is the working group 1 report for assessment cycle 6. You have a look here. This was released in 2021. You have a look at this. This is summary for policymakers. This is a SPM. This is not a report. So it is the SPM for working group 2. This is the SPM for working group 3. So just by having a look here, you can make out what are you basically handling. Okay. What is working group 1, physical science basis? What does it contain? It contains the understanding of the state. Basically, this is the entire science component of the working of the IPCC report. So how is the climate changing? What is the role of human influence? Because if you look into the climate, there is one natural variability component and there's another human induced or anthropogenic contribution. It means agar aap weather ko, climate ko aise hi dekhoge, if you observe weather, if you observe climate, the climate is not going to remain same through and through. It will vary. But whether it is naturally varying, which is called natural variability, or it is varying because of the human activities, say fossil fuel burning or other activities, anthropogenic. So IPCC studies, it basically tries to segregate what is the role of human influence. Then it will give you a knowledge about possible climate futures. Means now it is like this. Now how the climate is going to change. Now there are 3 words: possible, climate. It will look into the climate, how it is going into the future, and what are the possibilities. So it is not that we have only one future. Depending on how are we going to change our activities now, or what are the mitigation measures we're going to take now, we can have different possible futures. So when you talk of scenarios and projections, this is where your various possible climate futures come up. Understand it very clearly, because I'm not going to take you through what is the other findings. I'm not going to touch on finding. I'm going to take you through the terminologies, okay? Then it will give you, depending on different regions, how the information is relevant, depending on different sectors. So it basically gives you the information by breaking it. Says where you say, I'm a researcher or I'm somebody who's based in Southeast Asia. So go to just Southeast Asia, because IPCC contains everything. They cover. So what they've done is they've broken that information to different regions. Further, within that particular region, it has broken the information into various sectors. Okay. And then it will tell you the ways how you can limit human-induced climate change. This is all that is contained in Working Group 1 report. So now I'll take you through the interactive atlas, how to access the data. Okay. So I will first take you through a report. Okay. You are able to see my screen, no? So this is the IPCC Now, this is the IPCC website. I will just take their reports, their synthesis reports, working groups. You go through it, it's a deep sea. You can get lost very easily. I'll go to the reports part, okay? So this is the screenshot I've shown you. Let me go to physical science basis here, okay?
Ma'am, we can just see the presentation. No, can't see that.
You are not able to see this? Wait. Resume share. I think I have to stop share and start again. Okay, just wait.
Yeah.
Now you're able to see?
Yes.
Yes. So what I've done is I'll just go back here.
Yes.
This is the IPCC website, and in the IPCC website, I have gone to the reports part. Okay, and reports mein I have selected physical science basis group 1. Okay.
Yeah, it
So
started.
Okay, now see, it is a huge website. How to navigate, you should know. I am just going to tell you how to navigate. The science is too much. I cannot finish it within even much longer durations. But now it is asking, read the reports or the authors. So don't go into authors. Say, suppose I go into summary for policymakers. Okay, here. So this is summary for policy. How do you do it? So this is summary for policymakers. Now come down here and you find these are all the authors, drafting authors. They're not lead authors because this is summary. If you go to the main report, you'll say authors. So these are all the authors with their nationalities. So this is so you look at just for making a summary for this working group 1 report, these many authors from different countries were involved. These are contributing authors. I told you the first one, see Professor Achyuta Rao, he's from IIT Delhi. First you see here only. So you have the contributing authors. Now when you cite it, so the thing is when you cite it, you will come to know what is this. This is climate change 1, physical science basis, working group 1. To what? 6th assessment report. Which report? IPCC report. And then you find this is your DOI. DOI means, and this is published in 2021. So from the citation itself, you can make out which working group. This is summary of SPM, working group 1, IPCC. Okay. Now you come down here. This going to take. Now this is SPM only, so still late. It is giving you a current state of the climate. Now I will just tell you, I'll not go into the content. Look at this. It is giving you references here. You know, the first statement it makes it is unequivocal that human influences warm the temperature. So and so, widespread and rapid changes in atmosphere, ocean, cryosphere, and biosphere occur. This is one statement. Now, if you want to know more about this statement, that what has been the human influence, how it is, how widespread it is, how it has affected the atmosphere or the ocean. So if you want to basically deconstruct this sentence, you can go to chapter 2.2, chapter 2.2.3 of what? Of working group 1, because this is the synthesis report. Okay, this is a SPM. You can go to cross chapter box so and so. There's a cross chapter. You can go to box 2. So basically, this is how. So if you want to know more about this statement, this is just one statement. You can go to all these references. 9.5, 9.6. These are 9 means this is chapter 9. 9.6 means 9.6 of chapter 9. Cross chapter 9.1. So you can go to chapter 9. Look at box 9.1. You can also go to SPM 1 ka. SPM ka 1 ka figure or SPM. SPM means of this SPM, you can go to figure 1. SPM ka figure 2. Now you look at this. To support this statement, 8.1, this is the supporting evidence. So this is the supporting evidence here. Now it has given you a lot of things that for doing this, you since 2011. So I'm not going to go into content. Look at this statement, high confidence.
What does these references are part of this PDF only, or we have to refer something else?
See, these references are part of this.
This PDF.
This PDF, and when you go to 2.2, 2.2 will then contain further references. Okay. Sorry, this is 2.2. 2.2 is working group 1 report ka 2.2. This is a synthesis report. This is a SPM. So these references are 2.2, 2.3 are from working group 1 report.
The larger report, like the normal physical science report. Yeah.
Physical science. So this is from these references because it has got about 9 or 13 chapters. I don't remember as of now. So this 2.2, 2.3, this is because this is just a summary for policymakers. This is a small summary. So these references take you to the main report, WG1 report, because this is the SPM for WG1. Okay. Understood?
Okay, got it. So we need to have both the reports side by side to kind of understand. Okay.
Yes. So basically, if you go through this, so if you say, just to give you an example, you want to, you go to this concise report, which is a SPM, and you are, say, suppose you are the purpose. You want, say, suppose you are working on, say, land or on ocean or an industry or on health, anything. And you want to find out for that particular, say, suppose, just to give you an example, that what is going to be the temperature rise and what is going to be the implications of those temperature rise on human health in Southeast Asia between the period, say, suppose 2050 to 2080 or whatever time period. Okay. So you want some scientific basis for that. So what you do is, in this, you can find out SPM name, where have references for health are there. Then on the references on health, you can find out in which sections the health section is elaborated in the working group 1 report. And from there, you can go through those sections and from there pick up the relevant data for health, impacts on human health in Southeast Asia. Getting my point?
Right,
Okay.
right. Okay.
Okay, and now when you read these statements, you, so say suppose they have given you example about observed increases in the mixed GHG emissions since 1950, and they have made some statement that these measurements were reported AR5, how it has changed over the years, and what have been the different distributions, whatever. So let us not go into statement, but at the end of it, it says high confidence, and it has given a reference 7 here. So what is the reference 7? It basically, in this statement, they have considered that land and ocean are not substantially sinks. Basically, with this, you go to the reference, but what does high confidence mean? You will find high confidence, medium confidence, low confidence, very low confidence, very high confidence. These are basically, I will cover later on what high confidence means. Depending on whatever scientific literature that has been reviewed, how much is the agreement within the scientific literature. So if you have a very huge agreement within the published scientific literature, that statement in itself becomes high confidence. If the published literature does not, say suppose they are, just to give an example, if this statement, supporting this statement or related to this statement, they have reviewed 100 literature. Of this, only 20 have a substantial evidence which suggests or supports it. So you'll say low confidence statement. So every statement that the IPCC makes, it has got a connotation of a confidence level associated with it. So you need to know how that confidence, what does that confidence level tell you? Okay. So now it is looking.
So so it's not there in this statement A1 point. It is there in A1.1.
Here it says unequivocal. Unequivocal means it is unequivocal. Means unequivocal means it is there. उसमें confidence का मतलब ही नहीं. It is there, sure shot. If you look at these statements on human influence on global warming, you will find with every assessment report, they used to say that very high confidence. It is virtually confident. So those terminologies. In AR6, they have used, for the first time, they used the term unequivocal. Unequivocal means all the evidence, all the peer reviewed literature says that human influence has warmed. That's why they use the term unequivocal. That is why there is not a confidence statement along with it. So if there's an unequivocal statement, there'll be no confidence statement associated.
Understood.
Yeah. It means there's total agreement, basically. Okay.
Yes.
So I wanted to take you through some places where you have said these are likely, these are very likely, extremely likely, less likely, medium confidence. Now, when you're talking of retreat of glaciers, very limited evidence, there's medium agreement. So wherever it, because, you know, if you are reviewing 100% or whatever set of literature you're reviewing, not every literature would tell you the same thing. No? Say, suppose you have some, over India, you find some, say, just to give you an example, melting of Himalayan glaciers. So you might have 100 peer-reviewed journals on that, articles on this. Some would have some degree of, some probability, some would express some probability, some would say September mein zyada barish hai, October mein kam hai. So whatever, and then what the IPCC does for that particular region, it will take everything and they'll tell you that how much is the agreement within the various scientific literature. Okay. So here it says mentioned, it says TS 2.5, technical summary references bhi de raha. Now it is virtually certain. Now here they're not using the term unequivocal. Here they're saying high confidence, low confidence. Now, this is how human origins, how it has made. Now, if you look at, this is the observed, and because IPCC, as far as the climate science is concerned, a lot of places you'll find these types of graphs. So this is the observed changes. So how they are reconstructed changes. Now these are observed, these are simulated for human and natural. They're simulated only for solar and volcanic. So wherever see, the mix is huge. The mix is huge. So you should be knowing what type of data you are. So wherever it says observed means these are actual observations. Wherever it says simulated means, it means there's a model involved. There's some climate modeling component involved with it. Okay. So now, if you look at this now, yahan pe it is giving you a spread. It is giving you a spread because wherever you have values varying, so it will give you a mean value and the range. Okay. So radiative forcing value. Radiative forcing value means how much is the basically net climate, the solar radiations which are coming in, the solar radiations which are going out. So effectively, how much is the radiative forcing which is generated? So you will find lot of graphs here, but what data set you are dealing with, you should be knowing what terminologies you are dealing with. So first thing is the confidence level. Second thing, whether you're dealing with actual observations, whether you're dealing with simulations, whether you're dealing with scenarios, whether you're dealing with projections. So working group 1, this terminology you should be knowing. I'll cover it briefly later on. So this is how you navigate. Okay, I'll now go back to the presentation again. Okay, is the presentation is visible now? Okay. Yeah. So now we go on to what are the interactive. I want to take you through the interactive atlas also. I don't know how much time I have. I'll come back to it later. So we spoke about different confidence levels. So they are basically, because they are based on multiple line of evidence. So what is the level of agreement? It is also based on the quality and the quantity of evidence that is available in a published journal. And then what is the consistency and coherence on which the studies are based? Very low means very little scientific agreement, or little evidence. Very high means there's almost everybody agrees on that. Now the second thing that will come around is projections and scenarios. Okay. So projections are basically, you have to understand this because I'm going to spend about 5 minutes more on this. So projections are, suppose we say that these are the climate projections for 2 degrees Celsius warming. These are the projections. So projections, first things, are developed by using climate models. Okay. And what do these climate models capture? What I discussed earlier, like when I gave an example of a city. So all the interactions, the atmosphere, the land, cryosphere, whether it is the all these various mechanisms, feedback mechanisms that take place. And then those projections are based on certain scenarios. What are the scenarios? Right. See, just to sort of deconstruct it. Say, suppose I tell you that today we are in a certain state and we are going to be very stringent about, we are going to have a sustainability scenario. Means we are going to take certain measures in which you have to mitigate strongly, you have to adapt strongly. And then you put in other socioeconomic factors like how India's GDP is going to change, what is going to be the population rate, how the poverty is going to change, what are various factors, socioeconomic factors, sab laga ke we say, okay, these are the measures we're going to take. So you create a narrative, okay? On the basis of that narrative, you build a scenario. So what are the different type of scenarios I'll cover later on? And you say, if I take all these measures, then in this scenario, say suppose a stringent scenario, how the climate is going to change. So by building a scenario, you use a climate model, you feed the scenario in the climate model, and then what comes out of it is a projection. So if I take a set of scenario in which I'm taking no action, which is called a business as usual scenario in the climate change parlance. So if I take a scenario of business as usual, then it will give you a projection in which the earth is warming. Okay. Say we are going up to 6 degrees or 5 degrees, 6 degrees Celsius by the end of the century. So scenarios are used to develop projections. So it will give you how the future is going to be. Now, depending on what type of future I want, I'll have to accordingly tweak my scenario. Getting my point? So the projections will vary depending on what type of scenarios are used in modeling. What are the scenarios? They are hypothetical pathways. Like you are just sitting and creating a narrative. Okay, if I say, suppose, stop using coal now, then let me see if I stop using coal now, it is totally RE based energy generation, or maybe some sort of energy, 50% coal, 50% RE. Then my population is going to go this way. So whatever parameters you take, social economic parameters, then you feed all those into an integrated assessment model, which is called a IAM. So this IAM will give you a scenario. Okay. And that scenario will go into a climate model. And then that climate model will give you a projection. Okay. This is how it works. What the IAM does, the model does, is it will basically sort of put in together all your science and your social economic parameters. Purpose is to assess the policy. If I do this pathway, if I do that pathway, how the climate is going to change. That is done through a IAM model, which generates a scenario, and the scenario will give you a projection. Okay. What are the special scenarios? What are the types of scenarios? Now, if you have been reading IPCC, or if you have been sort of going through some news on IPCC report, these terms would look familiar to you. RCP scenarios, SSP scenarios. These are the older ones, SRES scenarios. So basically, when the third assessment report and the fourth assessment report, it used the scenarios which were, it used the projections which were used developing the SRES. This is a special report on emission scenarios. The IPCC developed those scenarios somewhere around late 1990s. So I will cover what the details are. So they were used in the published literature on these scenarios was used in the third assessment report and the fourth assessment report. Then the RCPs came in early 2000. Okay, so there are 4 RCPs, and they are basically based on the radiative forcing values. I'll not go into too much detail because I don't have the time. So the RCP scenarios literature was basically used in AR5. And now the latest AR6 has used SSPs. They are shared socioeconomic pathways. I'll cover in detail what are the factors which I use. So they cover a wide range of factors, socioeconomic pathways. So it covers all the social and economic parameters also. So the current synthesis report, what we have is, we have on SSPs. Now the SSPs, they have an equivalence with the RCPs also. You have to read more onto which SSP correlates to which SRP and whether they correlate totally or not. Okay. So the SRES, what I was saying, there were 4 scenarios. The 4 scenarios were A1, A2, B1, B2. A1 was a integrated word. It had 3 subsets. So if you have a fossil fuel intensive economy, how it will work. So this was one scenario. So depending on A1, F1 scenario, you will have one climate projection. I think if you understand this much, that is good enough. You can go into these slides later on at your own time. The second was A1B scenario, a subset of A1 where you have a balanced emphasis. It means it is a balance of fossil and non-fossil. Non-fossil may be your renewable, it may be your nuclear energy, nuclear-based power energy generation also. And the third one was emphasis on non-fossil, basically clean fuels. So you have 3 scenarios under A1. A2 scenario was a divided word. So how this economic growth is going to be, basically it was a high GHG emission scenario. So you'll have continuous economic growth. So they are basically all other socio-economic parameters. Then you have a B1 scenario, which was more integrated and more ecologically friendly. So when you use so B1 scenario will give you a different projection. So it will give you, say if it is a high GHG scenario, it will tell you A2 word mein kitni global warming hogi, your average temperature will go how much, how will your precipitation change, how will your sea level change, how will your, what will be the impacts because of this type of climate weather. So the entire scenario projection will be based on this scenario. I think if you understand this much, it will be good. So basically SRES had 4 scenarios. RCPs had 4. Now this 2.6, 4.5, 6 are, they are radiative forcing, 2.6 watt per meter square. So you can go into the details later on. But what does RPC scenario deal with? It basically deals with the peak and decline. So your emissions peak by 2020 and then they decline. So in this scenario, you find that in your projections that are developed using this scenario, by the end of the century, your warming was about 1.3 to 1.9 degrees Celsius. This is a higher radiative forcing, you find a higher global warming. RCP 6 is 2.6. We are currently, basically the way we are going, we are on RCP 6 scenario type right now. And 8.5 is business. You do nothing. So emissions, they continue to rise. So the warming by the end of the century is about 4 to 6.1 degrees Celsius. So what is your reference line? Your reference line is pre-industrial. Pre-industrial means before the start of the Industrial Revolution. So from there to 2100 to the end of this current century. So from here to here, the rise would be 4 to 6.1. You need to know your baseline. That is important. Okay.
Ma'am, just one question. See, we're talking about this rise. So what is the baseline temperature? Like,
Pre-industrial, I told you, pre-industrial.
no, what is the temperature? Is there like a value? Is there a value?
See, so pre-industrial, you'll have to go and see how much is the value, because I'll tell you what it talks about. Okay, let me deconstruct it for you. First thing, it is talking about a range. With me, 4 to 6.1 degrees Celsius. Okay.
Right.
6.1 is global mean temperature rise. So it's an average rise because if I say how much is the rise going to be in India, how much is the rise going to be say over Australia or over one particular region, then I will have to go into the projections for that particular region. Getting my point? So here I have, okay. So if you go to say, suppose you want to know India may under 8.5 scenario, how much is the global temperature? What is going to be the rise in temperature over Indian region? Okay. So what you do is, okay, let me just take you to this. I think that will be a better thing because bolne mein samajh mein nahi aata. Okay, so you're able to see the screen now. You're able to see the screen now?
No, ma'am.
Yeah,
You'll have to reshare.
I'll have to stop share and reshare. Okay. Okay, so what I'm going to take you now is to the interactive link. This is the IPCC site again. The link is there in the presentation, so you can browse it at your own time. Say, suppose this is the interactive atlas that they have generated under working group 1 report. Okay, WG1 you can make out, and this is 6 assessment. Now I want to see what you were asking was, I go into the regional information. Let me skip this. I reach here. So this is an interactive map. Say, suppose I want to know what is going to be, not the data set variable. So I want to see what is going to be the rise in the mean temperature. This is selected here, mean temperature rise. You want to understand what it is, just leave your cursor over it, it will tell you. It is mean near surface temperature rise. Near surface means closer to the ground. Okay. So this is the mean temperature. I take the mean temperature and I'm taking it, say, suppose I want to know between 2021 to 2040. Okay. Here. I want to know under SSP 8.5. You're with me, everybody?
Yes.
Yes,
SSP, yeah. SSP 8.5 is that it was RCP, right? 8.5.
This is because this is AR6. ARC is using SSP.
Okay. SSP. Okay. But it's the same, right? Okay.
SSP 5 is basically equivalent 8.5 RCP.
Okay. No, got it.
Okay. So abhi SSP I'll also covers. There are a lot of, actually you cannot directly correlate because RCP I think is 8.6 or something. But they are intermediate scenarios, so you'll have to read more on scenarios. Say suppose let me take SSP 1, which is 2.6. It'll be easier. Okay, RCP 2.6 is basically SSP 1. And I want to know here the warming is 1850 to 1900, so your last century. So you suppose I want to know baseline this is pre-industrial. I want to know with respect to 1995 to 2014, with respect to 1995 and 2014 period baseline, what is going to be my warming between 2021 to 2040. Okay? So this is your baseline, this is your scenario, and this is the period for which you are going to read your rise in temperature. So if you see, right. And I want to know over Indian regions, so I reach here. So if I put my cursor here, if you can see, I'll not move my cursor. If you see on the left side, you can see this temperature gradient.
The scale is there. Yeah.
So if I put it over Indian region, you'll find it is less than 1 degree Celsius. I move it, say, suppose to African region, okay, someplace over Africa. So I have to close this. I take it over African region. Now it has gone up to 1. I take it, say, over somewhere over Canada. That scale is changing depending on which region I've selected. Okay. I go over South Africa, South America. You find your scale is changing. So it means over this particular grid where my cursor is, the temperature rise is going to be what is reflected on the scale. Okay. Sure. Now, if I want to change it, what I'm currently seeing is annual value. Say, suppose I want to see peak of summers, June to September. Now you'll find the temperature value has changed. So if I say go over this region, you'll find it is 1 degree. You go over Middle East, you find this is how it is changing. You go over some other region. So there are so many variables with which you can That is the thing about good thing about interactive atlases. If you read about it in the IPCC report, you will not understand because that is too much information. But now here they have an interactive act. Depending on the variable, you want annual, you want custom, you want to customize your own season, you want to change the scenario, you want to change the baseline, you want to change the variable, you can play around. You can spend your whole day and just learn about ki 5 din mein kitna, some precipitation ke liye they see there's so many variations.
So, ma'am, they are country specific, right? They are not like, say, suppose if I want from Mumbai or whatever.
No,
They
not
are not
country
that
specific. They are region specific.
Region.
You see the grid, they are region specific. You want to learn about a city, say suppose you want to know about Mumbai per se. Okay. So what you'll have to do is okay, let me sort of I never want to step into it because it becomes more complicated. Now, when you run the models, that basically different types of models. One type of model is called a GCM, global climate model. Okay. So the global climate model will give you about the entire globe. And then you can cut it into grids. Like what you see right now is a global model. Okay. Now within the global model, they run on a coarser resolution. Their resolution is in some hundreds of kilometers. Okay?
Understood. Yeah.
Okay. So what you do is, if you want a finer resolution, you run a RCM, which is called a regional climate model. Say I'm in India में यहाँ जो grid लगाई है, but India में the Indian Institute of Tropical Meteorology is the nodal agency in India, IITM Pune, which basically does the regional modeling for India. It's a Ministry of Earth Sciences के अंदर आता है. So they run another model, another set of models basically, which is Cordex. So they run a RCM, regional climate model, which is a model run over a smaller region, but with a finer resolution. So their resolution is about 25 kilometers, tens of kilometers, 25, 30 kilometers की range में उनका grid resolution होता है, which basically caters to your city level resolution. So if you want, say, city के लिए क्या है, तो this process of sort of going from a global model to a regional model is called downscaling in climate modeling. Climate modeling, in fact, modeling is a very interesting thing, but a very complex subject. You need a separate dedicated session on that. So if you want a city level granularity, you have to go down from a GCM to a RCM. Okay. And just to tell you, just to help you with, so these are the different regions. Now, if I read here, it says CMIP 6. This is, I think it's coordinated, I'm forgetting the name, coupled something about CBIP kabhi bhi full form. Basically, there are many models which are, there's a collaboration called CBIP. It's a integration project, coupled models integration project, if I'm not wrong. So there's a project which is run at the international level. So this is the 6th phase of the project. Now the parameter that I have chosen is a mean temperature rise. I am looking for, so what are you looking for? The parameter which is in this is, it is telling you here at the bottom. So I have basically looking at the near-term temperature for the period 2140. It is a projection. The scenario is SSP 1, 2.6. My baseline is 95 to 2014. The period I have chosen is June to August. And in this CMIP says that 32 models. So what you're seeing right now is basically an average of 32 models which has been displayed to you. So that is the degree of complexity. And if you will sort of be in awe that what is the type of data set that IPCC is dealing with it. The saddest part is that people don't know how to use this tool, don't know how to access this treasure of information. Okay. You look at the data
and
set also.
Ma'am, for the regional models also, we can, it's on the same website.
No, not the IPCC website. Regional model clay, you'll have to go look into publications as of now. Otherwise, you can request data from IITM. Their data is not, their data outputs are available. So you can go to IITM website and look at their projections, how interactive that is. I have not sort of seen the latest AR6 ke parallel, whether they've taken out or something or not. Otherwise, if you are a researcher, you can request data and IITM would share the model outputs with you. But whether they have an interactive website or not, I am a little doubtful. I have not browsed actually, to be very honest. I have to go and search. But they share their data outputs with you. And if, say, suppose you are a researcher who only wants the outputs, that can be done. Otherwise, they provide you metadata also. If you are a researcher in modeling, so you want to run, say, suppose within an RCM, you want a nested model within a RCM, so a much higher resolution. So you can request data, run your own model. So that is what for research purpose. So suppose you want to run over a smaller region, 200 kilometers, 300 kilometers. So IIT say you can get the data on request. Okay. So this is a huge. So यहाँ पे if you want to see, so you can see there are a lot of references, there are a lot of databases. यहाँ पे 32 हम CMIP 6 देख रहे थे. You can otherwise pick up Codex का see यहाँ पे regional model का RCM is available here. So if you want, you can see Southeast Asia. So uska Codex ka model, then it will take you to a smaller list. It will only run it for Southeast Asia here. Say I want South Asia. So if you see, it is running over this. So this is the RCM output. So now what you're seeing is just, it will display regions. Now here the resolution will be higher because it is a RCM now, the outputs. So you can play around with the data, just go through it. So Codex is, I think Codex is coordination experiment for RCMs, if I'm not wrong. So these are smaller models. You can see regional models. So it will have a smaller models here and what type of data sets you want to use. So there is huge spread. You can mix and match and utilize the output you want for one particular, but it will give you a region specific output. Okay. So what I want to tell you is that there is a huge amount of data and they have interactive, put it on interactive APIs. So you can play around with it. You can work on it. Okay. Now, where have we reached? Okay. So this was the interactive atlas. So we've covered this. The RCPs are here. So basically 4 scenarios on the SRES, 4 scenarios on the RCP. SSP is more complicated, is more advanced. I'll not say complicated, but the more layers you build into a model, the more complicated it becomes. So it basically SSP works in terms of adaptation and mitigation challenges both. So SSP 1, where you have both mitigation and as well as adaptation challenges are low. Your 2 is where you have intermediate. See, it's in the center of the line. So you have middle, intermediate adaptation challenge as well as mitigation challenge. Your 3 is where you have high challenges. That is how they frame the scenarios. There are 5 SSP scenarios. So, and basically the first one is the most rigorous one. We can say very low GHG scenario. You can go into the detail and can give you it gives you maybe a much more finer slicing of the data. So 20 years bracket, how the warming is going to be between 40 and 61. But this is just a gist. Okay, from the interactive atlas, you can understand that there are so many outputs that can be generated there. But this is the latest that we have in AR6.
Just to understand, just go back to the slide. So India would sit under SSP2 based on the net
See,
zero.
India can fit under any SSP. These are scenarios. Scenarios are narratives. They are storylines. Understand this. This is not the actual. See, if you look at climate projection, climate forecast, and climate scenario, you need to understand this distinction. If I say what is going to be the climate forecast, it means I will give them the inputs of current weather or whatever data set input I'm using, and based on that current input, it will just give you how the weather, climate is going to be for this particular decade wise. Generally, they are decadal, interdecadal output is give climate projection. Climate forecast means how the climate is going to be. It's an actual forecast. Climate projection is based on the scenario that you're using. So if I say that for India, how it is going to be, then I will ask you the question under which scenario. So if India uses a very low GHG emission scenario, it means India is going to be very stringent about keeping the GHG emissions low. So then the global, now again, these values will not be applicable to, these are global values. I've just, see, you have to go back again to the interactive atlas and see over Indian region, how it is going to be. Okay. These are global, the values I've given in the table are average global values. This is just to give you an overview. Otherwise, you'll have to go back to the atlas and see under SSP 1 over Indian region, how it is going to be. Under which scenario, under which period. So, getting my point?
Yeah. Why I'm asking this is, actually, this is very interesting, and I come from built environment sustainability. So we use a lot of weather files to simulate scenarios for energy efficiency and other parameters. I was just wondering, I work on large scale projects which will actually get finished somewhere around 2025 to 2030. So basically using the weather data of the past would not really help assess the future. And do we have methods wherein we can incorporate this temperature rise and then calculate? Because frankly, I was never aware of.
So you are working on, are you working on climate forecast, or sorry, your speech is little, which model are you working on?
So basically, I come from built environment sustainability. So we do this modeling, which is for basically buildings and infrastructure projects, large scale. And we use the weather data. We basically use the TMY files.
Then you must be using then you're using a climate, you are generating a climate forecast then, because it's a pure climate model, or is it a model which is running on a scenario? That distinction you need to be, what is the type of output that you have?
It's basically a comparison between baseline and proposed. Proposed would be the design that we're proposing, and baseline would be a scenario that is dictated by the codes that we follow.
But but your inputs are only climate weather related inputs?
No, there are other building related inputs as well, but of course, basing on the weather data, right? We input that. So my only thing was, so basically, we are not using the right projections of the weather data as we need to. And that is what I was
see, because if you're working on buildings, means infrastructure, I'm getting it correct, na? Infrastructure, yes. Your work.
Largely infrastructure with, for example, a port.
Okay. Project. So then, so say suppose you are going to forecast, then you need to know that how your own weather is going to change. Just to give you an example, currently, which scenario are we going to use will depend on, we are not on SSP1 right now. Or maybe if you look at, we are currently on, if you look at India, we're currently at SSP3 maybe, broadly speaking, because you look at the type of policies that we have, and the scenario maybe it is not that SSP3 is a fixed scenario for that matter, because there's so many variables, how your population is going to change, how your GDP values are going to change, how your energy mix is going to change. There are a lot of variables that go into it. And what is your current policy mix? Say suppose, just to give an example, if the average GHG emissions of India are a certain level, but my policy is not stringent enough to sort of arrest the rise in the GHG emissions. So your policy also goes as an input, current policy also goes as an input into your, say, as of now, we have what type of commitments we have, or what are the policy interventions we have. The international commitments that India has taken over is in terms of emission intensity of GDP. We haven't said that we're going to cut down our emissions by so many percent. We are telling that we're going to reduce the emission intensity of GDP by, initially we had committed to 30 to 35%. Now we've said 45%. So it is a mix of emissions and GDP. It means emissions divided by GDP. So if your GDP is high, your intensity goes low, but your emissions are high. So, it's a very complicated mix actually. So what SSP, basically it is not a fixed SSP. Within that SSP, I've given you a broad SSP. So there are intermediate SSPs also, depending on what are your input values for various socioeconomic parameters. And in that, your energy mix and your policy mix also plays a very major role. Right. So you'll have to basically revisit what are your variables that you're feeding into your model. And then you see what I've given you as SSP5, 5 SSPs. No, this is also an overview I've given. There are intermediate SSPs also, 3.6, I think something like 2.6. ये बहुत intermediate SSPs भी होते हैं. Because I cannot cover everything, so I've sort of kept it an overview. So revisit what you're doing, because if you're going to give them a sort of key how the infrastructure is supposed to be so that it is able to say continue for another 50 years, then you need to know that place where it is situated, what is going to be, how the weather climate impacts are going to change. Now, how the climate impacts are going to change over a period of time, or what type of future are you going to face that particular region, will depend on how your emissions are going to change, because that will guide your weather. And the emissions, how they're going to change, is going to be guided by too many things. What the inputs that you change, what is your social position, what is your, what is your educational status, how is your GDP, how's the health, how's the population going to change, what measures government has taken to take. The mix is huge. So you basically need to revisit your input variables. Sitting today, we cannot say the same type of infrastructure would, well, I'll not make the same recommendation if we have a government which is pro say net zero, and say suppose next phase we have a government which is not pro zero, let us go to business as usual. Then your entire future climate is going to change depending on how your policy mix is there, and also how stringent your policy implementation also is. That's a separate debate altogether. Okay, so I'll just put it here for the sake of time. I'll put it, sort of keep it here. So the next is, I will now sort of mota go over it because I need to leave some time for discussion. So the second part, IVA, is basically, it talks about impacts and risk, how the weather is, what are the climate impacts going to be, and what type of risk do they pose. So when we talk of resilience, like what you spoke about your infrastructure, how resilient would that infrastructure would depend on what type of climate you're going to be. Uske hisab se you'll have to sort of, to make the infrastructure resilient will depend on the type of future you're going to be. Accordingly, those factors need to be incorporated. So it gives you a picture at global level, regional level, lot of factors are packed into it. So adaptation in terms of how the ecosystems, biodiversity, human communities, what are the impacts going to be on them, what type of risk, and then what are going to be their vulnerabilities. Because in one particular region, say suppose, just to give an example, somebody asked a question about Mumbai mein pata kaise chalega, no? But say suppose this, you have an extensive, I give that example of heavy precipitation of Mumbai because it stays with me. But if you have a heavy precipitation in Mumbai, the vulnerability is not going to be same for every citizen of Mumbai. Somebody who is from a higher income group will have less vulnerability because their exposure to that rain will be less. Suppose I choose to stay in my office, the streets are flooded, so I will stay put in my office and I have a office space which can accommodate me in the night. But somebody who's a vendor who works on the road has got no choice. So my vulnerability and that person's vulnerability is going to be different depending on how much is the exposure, depending on what is my economic status. So your vulnerabilities also vary. So and what capacities you have, very complicated mix again. And then it also says that no matter how much you try to adapt, there's still limits to adaptation. Say suppose your temperature is going to go by 4 to rise. Say suppose business as usual scenario, temperature rise global is 4 to 6 degrees Celsius. Then you can adapt only up to a certain extent. Uske baad, say suppose I take example of heat stress. The heat stress is going to take me after that. So uske baad kya hoga? Adaptation can work only up to a particular limit. So this report also talks about those limits. Okay, I'm not going to go into the report because we don't have that much time. Then mitigation talks about all the steps that we take to reduce the emissions. So it examines the sources. Then how can we bring about emission reductions? What are the effects, measures we want to take? And all of you who are familiar with the climate policy and the debates that go on, you must be conversant with a term called NDC and long-term emission goals. NDC are naturally determined contributions. Not naturally, nationally determined contributions. They are basically commitments that every country has taken up voluntarily under the Paris Agreement. Okay, we are going to do this about climate change. So India has about 8 goals under our NDCs. And for those nationally determined goals, then what are the policy measures that we're going to take? How are we going to achieve the NDCs? So there's another process called global stocktake, which the IPCC is going to support, because Paris Agreement was came into force in 2016, adopted in 2015. And they said, okay, whatever pledges we've made under the NDCs, we are going to revisit it every 5 years. So 2020, every country was supposed to revisit it, but unfortunately, COVID had hit during that time only. So by 22, 23, most of the countries have submitted their new pledges. Now, whether the pledges that we made 5 years ago, we've actually made some progress on it or not. So that is going to be reviewed under a process called global stocktake. And IPCC, being the scientific body, is going to support the global stocktake process also. So all of you who want to follow IPCC in its work, the global stocktake is currently on, because it was supposed to take midway between the NDCs. So it takes place every 5 years, but midway between the NDCs. So 2.5 years between the NDCs. So currently the global stocktake is on. So follow the news on global stocktake also. It'll be very interesting. Now, these are the special reports that I told you, that I mentioned earlier. So the one on ocean and cryosphere, this is the SPM for this report. This report was prepared by working group 1 and 2. Okay. This is the one on climate change and land. This was prepared by all the 3 working groups. And the one on 1.5 degree, all the 3 working groups was involved. Browse the site and try to find out what all is there. So this is usually, if somebody says SR 1.5, this is basically special report on global warming. This is what I've written here is not the explanation. This is the full name of the report, special report on the impacts of global warming. So it's a huge title it has. In short, it is known as SR 1.5, brought out in 2018. And basically what it does is that 2015 Paris Agreement said, ask the IPCC that you prepare a report that if we have to achieve a average warming of long-term goal, limit the warming, not achieve, limit the warming, global warming to 1.5 degrees Celsius by the end of the century, then are we on track or not? What are the measures there? What scenarios should be there? What pathways should be there so that we reach there? So requested in 2015, the report came out in 2018, and it was huge. At that time also it was mentioned as it was a red alert. They said the trajectory that we are now, we are going to surpass 2.5 degrees, 2.2, 2.5 degrees Celsius, the current path we are on. So that's all the scientific evidence is collected, presented. One was on climate change and land. It came out here. This is the title of the report. It is called SRCCL, Special Report on Climate Change and Land. And this is special report on ocean and cryosphere in a changing climate. So these are three special reports. I've only covered three. I'm going to cover a few more things. Methodology report. All of you who are interested in GHG inventory. So what the methodology reports are, they basically prepare guidelines for how to prepare your greenhouse gas inventory. They have some good practice guidance, means how you should be preparing your inventory. And then they bring out revisions of these practices. So the latest we have is the 2019 revision to the 2016 guideline. I'll take you through I wanted to take you, I don't know how much time we have, not much, but I've given the link here, browse through it. These are the fattest in the terms of biggest reports that you have, very complicated. And you need to basically take a short course on how to, if you want to do GHG inventory and understand that. So their methodology reports are basically related to greenhouse gas inventory. Then these are, what is it here? So just to cover up on what I have covered today, I'll be less technical tomorrow, but then go through these slides today and see if you're able to navigate through the website. It will still take time, but just see, get yourself familiar. How can you play around with the data? How can you extract relevant information depending on your field of interest, and and how this information can be used in different areas in terms of research, in terms of businesses, in terms of policy making. That I'll cover tomorrow, because it is otherwise a huge database. So today what we covered was basically how it works, what are the type of reports, how they prepared, reviewed, how can you engage. Few terminologies and concepts I've introduced. It is huge actually, so I would not be able to cover, but in case you have any doubts, you can ask today, you can ask tomorrow also. We have a session tomorrow. And then we covered the how to navigate to the website. Now what I've done is one case study I have prepared. Now Pratiksha will have to come in here and see how we break the participants. Basically it is just to help you get familiarized. So you can pick up any of the I have picked up India. So you can divide these three things amongst the three groups, that using working group 1, 2, and 3, because you'll have to see where to use what. So you can do it for India. If you want to, maybe you have more time, you want to browse more, pick up some other country, and then all the three components for that particular country. See what are pick up any three impacts, observed impacts and projected impacts. So you should be able to read, say, suppose they say the observed impacts will remain the same, but projected impacts will change depending on the scenario. So pick up any three observed impacts and their projections in the future, and then see under which scenario are these impacts are being talked about. Then you can pick up 3 adaptation recommendations for any particular region if you want. I've seen, you can maybe India, some other, and mitigation actions. So my basic motivation, my basic objective is, then when you look at the first component, you'll have to go to working group 1 report. The easiest way that you can do is first go to either the synthesis report, so not the synthesis, sorry, the summary SPM for that particular report. So go to the SPM, do a word search. So just do a find karke uske words ke search karo and see where all, because otherwise if you sit and read it, you will spend a lot of time. So do a word search. It will take you to that particular word in the entire text and see wherever it is taking you, whether that is the relevant information that you're looking for. Say, suppose you want to do on about, say, health. So look at human health. You want to look into ocean, or you want to look into vulnerability, or you want to look into anything, land use or energy or anything else. Do a word search in the working group SPM. And from there, then you can sort of, jitna you want to explore, there's no end to the IPCC data. So, and what I would like is that you use the certain terminologies. Actually, suppose you want to make a statement, there's high confidence that this is the observed this thing, or this is medium level confidence on this, or maybe some other terminology that you can pick up. Okay. And if you can, there's a huge, if you go to the website, they have infographics and figures, separate segment on that. So you can, if you can use few infographics and figures, nothing like it, because it is always better. Infographics it's easier to present data, it's easier to understand data in terms of infographics. So this is the project I have. This is the case study that not much, just 3 impacts observed and projected, 3 actions, adaptation actions, any area you can choose, 3 mitigation actions, any 3 you can choose, any area also you can choose. But I just want you to navigate the sites for all the 3 working groups. Okay, with this I finished. I'm open to questions now, and even if you overshoot a bit, if you have time, I am ready to engage. So I will stop sharing my screen now. Pratiksha, would you like to come in here and distribute the work, or you can do it later? I leave it totally on to you. We can have a maybe 10 minutes discussion on this tomorrow at the beginning of the session also, in case the participants have doubts now to discuss.
Yeah, cool. Sure. So what all you want to do now? I have to ask them, right? Hello, everyone.
Hi, Pratiksha, I would like to ask a few questions, if it's all right.
Sure. So can we do case study to, like, you guys, I'll give you few names and segregate you in the group. You guys talk to each other. You have your number on the WhatsApp group, and then come up with something. So how do you want a result, Abha? It's going to be on a deck or normal document, or how do you want to text format as a result?
If you can make maybe 2 slides, 3 slides on it, present it, because I want to see some, some data that isn't picked out.
Correct. So I'll do division, and tomorrow we can discuss in 10 minutes. Right now, let's wrap it up, because today it's too much to process on a first day. So is it okay, everyone?
Yeah, I think.
So if you have anything to ask, you can ask me now. I'll start with this. IPCC is very complicated. I've thrown a lot of words on you. But if you can go sit at your own time when you browse through the website, you can either go to the text if you're looking for certain findings, certain statements that you want to use in your work otherwise, or if you want to just get acquainted with how the entire interactive way is the most beneficial way in terms of understanding also, because there are so many variables that are at play. So just familiarize yourself with it. And if you have any other questions you want to ask, I am available.
Hi, Abha. I would like to ask a few questions, if it's all right.
Yeah, I would request who's asking, please put your camera on. It's easy for me to relate face to faces.
Okay, just a moment. Sorry.
Okay, if you can ask, if you have some, okay, take.
I'm not sure if you can see me, but so I am a GHG data analyst. So I had a few questions pertaining to my area of work as well, because this coincides with what you just taught us right now. So first I wanted to ask you was, is there any body which gives policy prescriptive assessment and publishes it globally for all countries to follow?
No, see, I'll tell you, because IPCC is a part of the UN network, United Nations network, because WMO and UF together, UN is the guiding principle is it respects sovereignty, national sovereignty. National sovereignty. So every country has a freedom to decide what they want to do in their own. The international body which works under the UN umbrella will never be prescriptive.
Right.
So they can always make recommendations. It is onto that is why your political leadership of that particular region plays a very important role, because how your policy is guided is basically, you know, at the end of it, the science base is very strong, but the push from the top comes, what is your political will? So there is no body which gives you a policy prescription. They'll give you a policy spread in terms of what all is available. What all to pick and not to pick is your national government's responsibility.
Got it. Okay. So recently we have seen a huge rise in, you know, SBTI commitments, science-based targets initiative, and they have prescribed aligning to 1.5 degrees Celsius scenario, less than 1.5 degrees Celsius scenario.
Which body are you talking about?
Science-based target initiative.
Okay, sorry, I'm not aware of that. Okay. Is it an international initiative or a national initiative?
International. So a lot of companies are committing to net zero through that, and they just certify whether our emissions are, you know, whether that whatever we are reporting is reliable or not. So I just wanted to see if maybe it's not here, but I wanted to see.
Your speech is cutting off.
Another thing I wanted to ask was,
can you repeat? Your speech is cutting off.
Can you hear me now?
Yeah.
Sorry, can you hear me now? Okay. I wanted to ask, as a GHG analyst, which report must I refer to? Is it the SPM that you would suggest?
You are working on GIS or GHG?
GHG. So basically, I calculate carbon footprint emissions for different organizations, institutions.
Okay. So, and you are okay. So I'll tell you what you're asking is, there are too many layers to it. Okay. So if you're looking at the greenhouse gas inventory, what are you looking for? What are you looking for? First, tell me this.
Greenhouse gas inventory, but I would like to know how different climate scenarios would impact, say, a certain type of company, if it's a manufacturing company, or if it's a fuel related company, or if it's a textile industry, how changing climate scenarios would affect a specific type of industry, and I could say devise a mitigation strategy for them. So what sort of report would be ideal for me to refer to?
So what you do is that you look for, you go to the IPCC website, you look for their regional projections, and in those projections, you'll have to find out that the projection, that the scenario that you choose is most similar to the scenario that we are, that the scenario Indian government is adhering to, or this. Otherwise, okay, let me tell you this. Go to Niti Aayog site, and they have a tool called IESS 2047. India Energy Scenario, or इसका मुझे last नाम याद नहीं आ रहा, IESS 2047. So what they've done is they have used India specific scenarios, and it is based primarily energy. The mix is on energy mix, and you can see, because that is aligned with what the government of India's policy are going to be. Okay. Another thing that you can look for is ISS scenario में pick that which scenario they say is the most. हालांकि नीति आयोग will never make a statement that this is the scenario Indian government is currently on. You'll have to use your own judgment on this, that which scenario, what policy mix they're using, and what scenario India is. Now, depending on that scenario, now it is subject to interpretation. Picking out the risks from that particular scenario for one particular region, what are the risks? Those you'll have to identify, and then how to formulate the mitigation strategy, that here where your domain expertise comes in. So that prescription of mitigation policy will not come from there. That they will say that this spread of mitigation policies are available. Now, depending on the risk that comes out specifically for one particular region that you're looking for, you'll have to pick up your own and make your own policy prescription for mitigation. Okay.
Got it.
Now, as far as GHG inventory is concerned, not the projections, inventory is concerned, you can go to either UNFCCC site where they have inventory for all the countries. Otherwise, India specific report is, the latest report is submitted, I think, in February of last year, which is the biennial update report, BUR 3.
Okay.
So it is available in Government of India website also. Otherwise, you can just do a BUR 3 India web search. So UNFCCC site में मिल जाएगा या ministry की site में मिल जाएगा, which has the latest inventory of India. So it is basically actual observed inventory. So it will give you a baseline. So that will actually give you a baseline, depending on which year. They give you a time series also. So whichever year you want to pick your baseline, that is actual observation-based inventory. Now, so that it gives you a baseline. Now, depending on which scenario, which prediction comes out, that you'll have to, that mix and match you'll have to do.
Abha, it's Arun over here. Over here, people just asked about the climate scenarios using about that.
Sorry, is it possible for you to switch on your camera, please? Is it possible?
I have a bandwidth issues, ma'am. Sorry for that. I in a remote village, actually, my hometown is in. Okay, sorry for that. Okay, actually, I just want to know that which climate scenario suits the best for the future projection, because if it is the global RCP 8.5 or 6 point something, it will be better, or regional specific will be better, because actually somewhere or some place in the world keep on emitting, in the sense there is no use in using the regional specific scenarios. I am thinking about it. What's your thought, or what's your expertise answer over here?
You see what I tell you. Let me again, now I'll go back to the RCMs and the GCM. So what happens is, when you run a RCM, which is a regional climate model, it does not run in isolation. It is always nested within a GCM. Nested within a GCM, matlab, the global model, one component, say suppose, just to give an example, you have a global model, so that it gives a projection about the entire globe depending on which scenario you use. Say suppose you're using RC 8.5. Now within RCP or SSP 8.5, you'll run an RCM. So when you run a RCM, uski boundary conditions jo hoti, boundary conditions means the grid that you've picked up, those boundary conditions, they match with our GCM. So ऐसा नहीं है कि if you under 8.5 it gives you certain projection for India, then that will be disjointed with a word. No, it would very good fit into that particular scenario into the GCM also. You're getting my point or not?
Yes, ma'am. I got it. Okay.
So it's conceptually, if you say that, India takes certain measures, and if only India takes certain measures and says US is not taking or China is polluting, then it is not going to make much of a difference, because climate is a public good. I agree. So that is why the entire climate debate is that developed countries have polluted so much, and the developing countries are bearing the brunt now, because उन्होंने pollute करा और impacts हमारे ऊपर आ रहे हैं. But when you talk in terms of projections and in terms of scenarios, then ये नहीं है कि RCM एक level में काम करेगा तो वो global में, it matches. Boundary पे, GCM की boundary पे जो conditions होंगी और RCM की जो boundary पे conditions होंगी, they exactly match. That is how the models are run. So the RCMs are run nested within it. Okay. Now, as a policy, this thing, whether some countries take measures, others don't take, it's a different debate altogether. True, but the thing is, climate is a public good. It's a global good. So, अगर मैं कम करूँगी, दूसरा ज़्यादा करेगा, finally impacts भी बराबर distribute नहीं होते हैं. वो भी कुछ जगह पे vulnerability ज़्यादा है, कुछ जगह पे vulnerability कम है. Impacts are also, unequally divided. So it's a different debate altogether. I will not get into it right now, because वो policy domain में चला रहेगा.
Thanks, ma'am. Thanks a lot.
So any other questions we have?
Hi, Abha. Just one more question. Sorry. I just wanted to know if we can perform scenario analysis on our own using any tools that are publicly available.
Yeah, you can have it. But the thing is, you need a very high processing computing power. That's the biggest thing, because even if you want to run for one particular, you need supercomputers basically to run. थोड़ा तुम RCM का या थोड़ा उसके नीचे को अंदर छोटा grid में you want to run. So I think you'll have to see what are the computing powers you need. You can run it, but the only thing is processing चाहिए. 2-3 things you require. First thing is you need a model, because they are all IPR protected models. So which model you want to run, that is one. Second thing, you need data to run the model. Second thing, you need a technical capacity कि इसमें data कैसे feed होगा, क्या होगा. So you need उसका basic capacity, थोड़ा technical capacity होना चाहिए. And other than that, hard infrastructure, computing power with you.
So the raw data that I would be looking at is my company's carbon footprint, for example.
Now
if
for that,
if it's business as usual, so how can
so उसके लिए you'll have to see, because I really don't know small scale models में. There are some models, some universities are running, but see, model में what happens is that so many things that you have to build into the model. So whether you have a model which runs at a mesoscale means within tens of kilometer resolution. So I have my doubts because they are usually housed within big institutions, and models otherwise are coupled. They are global projects which are running. So say 30 collaborations, 50 collaborations, GCMs ke alag hain, RCMs ke alag hain. Within RCM, if you have been doing, you have to basically do a search on somebody who's doing on a very high resolution, because I know some friends who are working on infrastructure resilience, and they do a little bit of modeling on a granular scale, say about tens of kilometer resolution pe kaam karte hain. But you have to get into that community, get in touch with people in that community who are working, because I'm not a climate modeler. I'm not per se into practicing modeling community. I can give you an overview and the scientific basis of it, but you have to get in touch with people. But there are people here. I can give you one or two contacts. Maybe send me a message. I'll give you a contact who's doing it for infrastructure resilience.
Right,
So
but there's no IPCC model which is like available for.
That will not work for a company level model. You're talking of, you have to look at the resolution. So
Right.
your RCM is about 100 to 30 kilometers. Your RCM is about 20-25 kilometers. It will not cover your industry level or a unit level granularity. Is not inbuilt. It's with the noise.
Yeah, correct. Yeah, makes sense. Thanks so much. That clarifies all of my doubts. Yeah.
So Abha, I have one question. So data they feed in, it's an assumption data, or they have taken from climate change exchange portal or something, or hypothetical data from any sites, like you said, Pune, they have a weather detection something system. So how they procure this data? Because I run it for a Genpact, which has a 21, which is situated in 21 different countries. And for them, I was creating a RCP and SS socioeconomic pathway. So I was taking all this 2100 का last था, and उसके बीच में बहुत सारे pathways थे. So I was collecting on the shit. Then I was creating a graph of it, ki how precipitation and temperature is going to rise, and if there was some things which I was not getting. I was doing the analysis because my manager was telling me this is how you should perform, but then later on I didn't understand how these scenarios which get scientifically approved, and how as a company that as Adani, I say that by 1.5 degrees by 2030 I'll be at 1.5 degrees Celsius. How they claim this? I mean, what are the things which comes under this? Before that, getting on the media, what process they place into?
So Pratiksha, I'll again go back. See, there are 2-3 things that you need to understand. जो SSV pathways हैं, मतलब first thing is you understand that pathway, what we say, or scenario, what we say, is a kahani. It's, in fact, the word that is used is called a storyline or a narrative. It's a technical term within a scenario. So what you do is you say that if I want to say, suppose I want to SSP1 kya hai, that let us imagine a future where we are going to have very less GHG emissions. है ना, एंड उसमें क्या होगा, हमारा पॉपुलेशन भी बहुत कम ग्रो करेगा, हमारा एसएसपी भी बहुत, हमारा जीएजी एमिशंस भी बहुत कम ग्रो करेगा, हमारी इकोनॉमी बहुत अच्छी ग्रो करेगी. तो हमने कहानी बनाई कि अगर हम ऐसा हमारा, इफ दिस इज द वे वी डेवलप इन फ्यूचर, सो लेट अस कॉल दिस मेथड ऑफ डेवलपिंग इन फ्यूचर इज वन सिनेरियो व्हिच इज SSP1, से सपोज, ठीक है.
Okay.
So now currently what you do is, I am here in 2023. What is the fact of 2023 कि हमारा PPM वैल्यू 400 PPM को क्रॉस कर गया है और हम यहाँ पर हैं, सब कुछ है, और हमारा अभी का वेदर ये है, ठीक है. तो अब अगर उसके अंदर मेरी, क्योंकि तुम वेदर को, क्लाइमेट को कैसे फोरकास्ट करते हो, इट इज बेसिकली बेस्ड ऑन प्योरली क्लाइमेट साइंस की टेम्परेचर, प्रेशर, प्रेसिपिटेशन, ह्यूमिडिटी कैसे चेंज करेंगे. वेरिएबल्स आर ओनली 4, प्रेशर, टेम्परेचर, ह्यूमिडिटी. बट उसमें अगर तुम GHG एमिशन को डाल दोगे कि अगर आज GHG एमिशन CO2 का इतना है, से सपोज 300 ppm है, तो क्या होगा, उससे तुम्हारा प्रेसिपिटेशन, बिकॉज वो हीट एब्जॉर्ब कर लेगा, तो तुम्हारा टेम्परेचर बढ़ जाएगा, उससे तुम्हारी क्लाउड फॉर्मेशन ज्यादा हो जाएगी. फिर तुम्हारे पास कोई फीडबैक आ गया, तो तुम्हारी GHG एमिशन क्या करती है, वो पूरी क्लाइमेट साइकिल को चेंज करना शुरू कर देती है. ठीक है, ठीक है. अब वो GHG कैसे चेंज करेगी, वो मैंने सिनेरियो से फीड करा है.
Okay.
मेरा हम क्या करते हैं, सिनेरियो को क्लाइमेट मॉडल में फीड करते हैं. अब उस क्लाइमेट मॉडल, ठीक है, तो क्या होगा, मेरे जो क्लाइमेट के पैरामीटर्स होंगे ना, प्रेशर, टेम्परेचर, ह्यूमिडिटी, वो तो सेम रहेंगे. वो मेरा स्टार्टिंग पॉइंट सेम रहेगा, पर उसमें जीएचजी कैसे चेंज करेगा, तो उससे टेम्परेचर चेंज कर जाएगा, तो उससे वेदर चेंज कर जाएगा, तो उससे क्लाइमेट चेंज कर जाएगा। वो मुझे एक कहानी, डिपेंडिंग ऑन मैंने जो सिनेरियो डाला है, जिस सिनेरियो के हिसाब से जीएचजी डाला, इट विल गिव मी अ प्रोजेक्शन। सो वो मुझे क्या करेगा, लो जीएचजी एमिशंस का एक प्रोजेक्शन दे देगा, मीडियम लेवल जीएचजी का एक प्रोजेक्शन दे देगा, एंड वो प्रोजेक्शन भी फिक्स नहीं होता है, वो एक रेंज देता है,
रेंज होता है।
ठीक है। एंड वो जीएचजी प्रोजेक्शन में कौन सा यूज करूंगी, वो डिपेंड करेगा कि एक्चुअली मेरी सरकार या मेरा जो आज की नेशनल पॉलिसी है वो मुझे किस तरफ ले जा रही है, whether we are going towards a low GHG scenario or a medium GHG. तो you have to understand कि जो projections होते हैं वो आपकी स्टोरी लाइन के हिसाब से they are plausible, उनके लिए पता टेक्निकल टर्म क्या, they are plausible future possibilities. फ्यूचर ये भी हो सकता है, फ्यूचर ये भी हो सकता है, फ्यूचर ये भी हो सकता है।
Got it. Yeah,
They are
I
not-
I used that word while I was creating a GenPact PPT, that there was, just now you mentioned that lower risk, higher risk, those terminology as well. We were using very precautionary measures. So if a client is asking how you came back to low risk and high risk, so we have the data, and always we used to use this word. Again, I think this is enough for today.
So if you don't, I think we have the number of participants also going down. It's a little late. So if you have no more questions, we can wind up, I think, today, and tomorrow
Yes.
we'll, and I will, it will be less technical today. Basically application part more, and we'll start with the case study, and uske baad any questions or whatever the way it develops. ठीक है?
ठीक है, चलेगा, ठीक है. Okay, everyone, bye. Thank you so much for joining.
See you
Thanks, Steve.
tomorrow.
Thank you. Bye-bye.
Thank you. Okay, bye. Bye, Abha and